We are going to start a new lecture series on finite volume method, and the lecture series will be finite volume method for partial differential equation. I should write the name of the series as finite volume method, finite volume method for partial differential equations. So this is going to be a very interesting series since we are going to learn a new method, finite volume method. The book that I'm going to follow is Finite Volume Methods for Hyperbolic Problem, and it is written by Randall Leveque, a very famous mathematician from University of Washington. In this first lecture, I'm going to present the course contents. So what we are going to study in this course, these are the course contents. As I said, we follow Randall Leveque book, and this course content is prepared from that book. We start from conservation laws, then we discuss finite volume method, followed by multidimensional problems. Conservation laws means that the natural laws that we talk about, like conservation of energy, conservation of momentum, and so on. Then we will talk about linear waves and discontinuous media. Then we will talk about the advection equation. Advection equation is a very popular model problem for to study the numerical method. There is one variation of this advection equation which is called Burger's equation, viscous Burger's equation, which is a model problem for Navier-Stokes equation. Whenever we study some numerical method, first we test that numerical method on the advection equation. We will talk about that in this section. Later on, we discuss diffusion and the advection diffusion equation, nonlinear equations in fluid dynamics. A very important consequence of these equations are the consequence of these equations is linear acoustics and sound waves. Whenever there is a noise, for example, noise pollution, then we study linear acoustics, and sound waves in that case. After that, we study hyperbolicity of linear system, variable coefficient hyperbolic system. We will talk about hyperbolic system later on, just to give you the glimpse of hyperbolic system. The meaning of hyperbolic system is when we have a coefficient matrix and the eigenvalues of that coefficient matrix are real, then such a system is called hyperbolic system. We will talk about that later on. Superposition of waves and characteristic variable. Then we have left eigenvectors acoustics again, and very important topic, domain of dependence and range of influence. Such topics are actually covered in CFD, computational fluid dynamics. As you can see above, we discussed the discontinuous solutions. Here again, we will talk about the discontinuous solutions and a very popular problem which is called Riemann problem, which is a kind of discontinuous initial condition somewhere in the domain, and we want to study that by using numerical scheme, which is finite volume method. Then we have coupled acoustics and advection initial boundary value problem. So until here, we only discuss mathematical models like advection equation, advection diffusion equation, so on. Later on, in the next part, we will talk about numerical schemes, which is actually finite volume method for these mathematical models. One of a very popular condition in finite volume method is the CFL condition. The CFL condition arises when we solve advection equation, either by using finite difference method or finite volume method. Then we have a very popular method like Lex-Friedrichs method, Lex-Venroff method, upwind methods, and upwind method for advection equation. In this section, our focus will be on advection equation. We will discuss what is advection equation in future. Then the Riemann problem is extended for Godunov's method for linear system. And the Godunov's method, as I said, it is the extension of Riemann problem. We will talk about that in detail over here. Then we have numerical flux function for Godunov's method. Later, we talk about flux difference, flux vector splitting, and Rose method, which is a very popular method as well. In finite volume method, these are popular due to certain reasons. Since we talk about fluxes at the faces of the volume, so we discuss Rose method, Lex-Friedrich, and other numerical method in this regard. Then we have a Lex-Venroff method, beam warming method, and some limiters. Then one of a very popular scheme to damp the oscillation is total variation. When we have some kind of oscillations like this, we want to damp it. We want to remove that from the solution. In that case, we use total variation diminishing limiters, TVD, slope limiter methods. And we have flux limiters as well. So these are the actually contents for this course that we are going to start finite volume method.